You will remember from yesterday's lecture that the final version of SSM that we are studying is called the four-step process, and inquiry takes place in these four steps. In the first step, the real-world problematical situation is analyzed and investigated. And based on our perceptions of the real world, several different purposeful activity models are constructed, which will then be used as a basis of discussion between different stakeholders so that they can arrive at an accommodation and decide for action. And action takes place in step number 4. And this cycle goes on and on without ending as a learning process. This is generally the process of soft systems methodology. Now, we have covered, I think, step 1 yesterday, and we started with step 2, which is the building of the purposeful activity models. We said that as a first step, we should construct a root definition, and we gave an example of a root definition. The root definition describes the activity to be modeled, but this activity does not take place actually in the real world. We are not trying to model the actual activity, but what we think of that activity. It's a notional. Notion is an idea, okay? A notional system, a notional activity system. So it is something that we think of rather than actually implement, and we start that with a root definition. Now, leaving aside the concept of root definition, which is very, very important, let's now see how we can construct an activity model. Now, we can propose a 5-step approach to construct these models, okay, in 5 steps. Model building takes place in 5 steps. The first step, it is very useful to memorize these steps by looking at the underlined acronyms or words. This is PQR. PQR is just not a very meaningful acronym, which means do P by Q in order to help achieve R. So PQR is a sequence, and the first part of the sequence, P, tells us to do something. The answer, and this something is the answer to the question what? What are we going to do? Q tells us how to do it, whatever we are doing, and therefore it's an answer to the how question. And R is what we try to achieve by doing P, okay? And that is the answer to the why question. So the PQR formula, you start with the PQR and identify what P is, what Q is, and what R is. Do P by Q to achieve R. The model builder has to be able to defend Q as a plausible how for the what defined by P. Now, you should be able to defend why you select Q as a method of doing P. Okay, you should be able to defend this. And the PQR allows you to write out the root definition as a statement which always describes the purposeful activity being modeled as a transformation process. Now, the reason why we spend time with PQR is because when we answer the questions of what and how and why, and identify therefore the P, the PQ, the Q and the R, then we shall be able to better formulate a root definition. The root definition of the activity, and the activity, the entire activity is best recognized is best thought of as a transformation process. One in which some entity is transformed into a different state. Now, so we are going to talk about the transformation process in purposeful activity models. But this transformation process is very specific to purposeful activity models, the SSM models, these special type of models. Obviously, we have talked about transformation processes for systems. A system is identified by some sort of a transformation process if it is a functional system especially, where there are inputs. And the transformation process transforms these inputs into outputs, as you know. For example, in the sawmill example, you could give me several examples of the inputs depending upon who is looking at the system, whether it is the industrial engineer or the owner of the sawmill or whatever. But you can say, for example, that the inputs to a sawmill system, it's a plant, could be timber, the raw material. It could be money, other materials that are required in the machinery, know-how. All of these can be assumed to be the inputs to the sawmill system, and the output could be finished products, or profit, or income, or some sort of satisfaction, etc. Now, this is in general what we mean by a transformation process. But here, the transformation process is much more specific than that, and please pay attention to this. It says at the bottom here, note that the transformation in SSM is very specific and different from the general concept. It involves the same entity being transformed from one state into another. So the transformation processes that we have to identify in SSM, in purposeful activity models, transform the same thing by taking it from one state and transforming it into another state. Now let's look at some examples. These examples are very useful. So you can see the process at the top. An input, which is some entity, is transformed into an output. But you see, the input is some entity, and the output is that entity in a transformed state. It is the same entity that goes in, which comes out, not something else. It's not like money or raw materials going in and profit coming out. That's not what we intend to mean by the transformation process. Some examples, a public library, for example. Consider a public library. The transformation process of this public library could be defined as follows. If the input is a local population, the local people living around the library, this is a public library, they can all come in and sit there and read books or borrow and take out books to read at home. If that's the input, the local population, then the transformation process transforms this local population into that population who are now better informed. Having read the books, they will be better informed. So this is what we mean by a transformation. Books, for example, if books are the input to the library, what are the output? Well, again, they are books, but they are dog-eared. You understand dog-eared? Yani yıpranmış böyle, kıvrılmış kenarları. Because that's what happens to books in the library. People reading these books, the books get worn out and become dog-eared. Another example for the library, local need for information and entertainment from books, records, etc. So the input is some demand for information, for entertainment, etc. And the output is that need met or that demand satisfied. Okay, local provision of education, if that's the input to the library system, then the output is that provision enhanced. Local provision, local supply of educational services, okay? And the library enhances that provision. Finally, books and other materials on the shelves. If you think that these are the inputs to the library, then what's the output? Books and other materials out in the local community. They are sitting in the shelves, but people come in and borrow the books to take them out to read at home. So the books get transformed from shelves to other people's homes. That's what we mean by transformation. The common idea here is that the outputs are the same as the inputs, but in a different state. We have another better example, maybe. All these examples are Cheklin's examples. The input I is transformed into the output O. it says T, the transformation T changes or transforms I into O. I must be present in O, but in a changed state. The input must be present in the output, but in a changed state. An abstract I must yield an abstract O. For example, material inputs like raw materials, and if you consider the output as profit, this is not a proper transformation because profit is abstract, materials are concrete. A concrete input must yield a concrete output. Example, possible T is relevant to a football match. Now, this is a better example, probably, or as good as the library example, a football match. Now, the players, if the players are the inputs to the football match, then the output is tired players. Having played the game, they are tired now. Yani, zinde oyuncular, yorgun oyunculara transform ediliyor. The pitch, the pitch is the football field. Churned up pitch, churned up. When you step on the pitch with a football shoe, some of the grass comes out, etc. That's what we mean by churning up. Rules having been applied. Football skills, for example, if football skills are an input to the football match, then the output are, again, football skills, but now developed, probably, because of the experience of having played the match. The team spirit can be transformed into increased team spirit or diminished team spirit. I mean, if the team is beaten, maybe the spirits will go down rather than go up. So, two wrong answers. Players transformed into football skills displayed is not a transformation process. It's not a correct transformation. Or players, referee, rules, pitch, ball, these are all the inputs to the football match, which produces entertainment. This is correct as a transformation, but not the transformation we have in mind. Okay, this is wrong for the SSM transformation, an incorrect example. Okay, I think this is clear. So let's go on. We are going on like this. Number one, the PQR. Number two, we identify the transformation process. In number three is called CATWO. This CATWO is an acronym again. It's very famous, CATWO. It is, if you ask CATWO, if you put this question to Google, you will get many references. CATWO is an acronym put together for SSM. This is what is it? It's a completely general model, a completely general model of any purposeful activity declaring exactly what we mean by purposeful activity is shown as CATWO. Start the process by defining each of these C, A, T, W, O, E is something that you have to identify in CATWO. First, start with T and W, and then the others. We shall see what these are in a moment. Then consider what would be the measures of performance by which the operation of the notional system would be judged. It says, how do you implement this step number 3? This is step number 3 in constructing the model. Step number 3 is what we call CATWO analysis. So you will do this CATWO analysis in step number 3. How are you going to do it? Well, it says here, start with T and W, the ones in the middle, the elements in the middle, and then identify the others. Actually, identify the measures of performance, etc. Now, let's see, first of all, what CATWO is. This, instead of writing it in words, I'm trying to explain it in Cheklin's diagrams, using Cheklin's diagrams. As you can see, let's start on the right-hand side at the top with O. O stands for the owners. Owners who could stop the process T. The T is the transformation is central to CATWO, as you can see. It is sitting in the arrow in the middle, T, the transformation process. the arrow indicates that there is some sort of transformation taking place. Okay? Now, O are the people who could stop the transformation process. We identify the O as the owners who have the authority to control the transformation process. C, again, are people. We are starting with people now. O are people, owners. C are customers. These are people affected by T as victims or beneficiaries. Okay? A transformation process can be beneficial to some people, or it may not be beneficial. Some people may have to suffer the outcome of the transformation. Instead of obtaining a benefit, they have to suffer. So the beneficiaries or victims, in that case, of course, if they do not benefit, they will become victims of the transformation process, are the customers. The other group of people are the A. The A are sitting in the arrow, as you can see in the middle. These are the actors. Actors who would do activities which make up T. These are the people who do the activities which makes up the transformation. These are the people who the transformation is implemented by A. So those are the people. Now, at the very top, it says a purposeful activity as a transforming process based on worldview W. So now we have identified the 5 elements of CATVO. T is the transformation process. We have to identify that in the first place. We know in order to identify T that T has to be based on some sort of worldview W. So we have to identify the Weltanschauung that drives the transformation process. The W is a driving force. It drives I mean, if W is different, T would be different. Okay? So all the 5 elements are identified. The remaining element at the end is E. E is at the bottom here. It stands for environment, E. Environmental constraints which are taken as given in doing T. Okay, these are taken as given when we are doing T. What are these E in our language, in our systems thinking language? What's the other word for E? These are the boundary judgments, taken as given. A boundary judgment is just a set of assumptions. We assume that the part of the system will behave so and so. That's what we mean by boundary judgment. So these are the E in CATVO. Formulation of root definitions, therefore, will be facilitated, will be easier to implement, to formulate if we use this analysis CATVO. So C is the customer, who would be victims, beneficiaries of the purposeful activity. You can identify C by answering this question. You can identify the actors A by answering who would do the activities. The activities, when they come together, form the transformation process itself, okay? Who would do the activities? What is the purposeful activity expressed as the transformation process? That's the question to identify the T. What view of the world makes this definition meaningful? I said that the driver of T is W. Driver means which imparts or ascribes some meaning so that people will do that transformation. O, owner, who could stop this activity. And E, environmental constraints. What constraints in this environment does this system take as given? So these are the questions that you have to put to yourself in order to complete the CATVO analysis. We said here that how do we implement CATVO? We do not start with C and then A. We start with T and W. That's easier always. Start the process by defining first T and W, then the other elements. When you identify all the elements, what you should do is is written here in the next step. Then consider what would be the measures of performance by which the operation of the notional system would be judged. In other words, what are the criteria that you are going to use in order to judge whether the notional activity system, or more specifically, the transformation process itself, is going to achieve? How can you judge that? The answer is here. The criteria that we are going to use are already what we know, the 3 E's. Actually, these can be extended to 5 E's. Criteria to tell whether the transformation T is working in the sense of producing its intended outcome. Is the transformation working? Is it transforming the input into the output as we expect it to do? Is it capable of doing that? That's the efficacy criteria. Efficacy, as you know, means is it working? Criteria to tell whether the transformation is being achieved with minimum use of resources. This is the criteria for efficiency. And finally, the criteria to tell whether this transformation is helping achieve some higher level or longer term aim. Is it serving our longer term aims or objectives? That's, of course, what we mean by effectiveness. The 3 E's will always be relevant in building any model, but in particular circumstances, other criteria might also apply. Now, in addition to these 3 E's, we could also consider 2 more E's. The second one, the fourth one is elegance. Is this a beautiful transformation? Huh? Now, it may come to you as not very meaningful to ask whether it is elegant or not, but believe me, this is very important, elegance. Elegance in Turkey is what we don't have. Aesthetics in Turkey is very poor. You can see the discussions about statutes being cut off, geography being altered without any concern to aesthetics and elegance. Huh? So elegance is very important. For engineers, elegance is very important. An elegant solution is a good engineering solution is always elegant. Huh? Elegance. Ethicality is also important. The answer to this, it's the answer to the question, is this a morally correct transformation? Ahlaken savunulabilecek bir transformasyon mudur? Okay, ethicality. So these also can be used as measures of performance for the purposeful activity. In number 4, we are coming now. What we are trying to do is, at the end, in step number 5, we are going to finish with and have the construct the model itself. But now we are approaching in steps to the conclusion of the model, to the completion of the purposeful activity model. And we said at the very beginning that the most important concept for purposeful activity model is that of a root definition. First, you have to define what activity are you trying to model, what notional activity are you trying to, or system that are you trying to model. So in number 4, we go back to the root definition and make a distinction between 2 types of root definitions. Root definitions can be either primary task or issue-based. Are root definitions primary task, or are they issue-based definitions? I did not put in an explanation, a definition of what we mean by primary task and issue-based. We can define it in words, and you will see it in the textbook and in all the exercises. You will get exercises on these. A primary task root definition would describe a purposeful activity which is composed of physical activities. Like, for example, painting the fence of a house. Huh? What you do there, you obtain a box of paint, you obtain a brush, and then you paint the house, etc. These are activities. So such a root definition could be called primary task-based root definition. How about a root definition which is issue-based? For example, we can hold an activity together here, deciding about how to evaluate your performance in this course? Suppose that I am a very democratic instructor, so I discuss this with you, the assessment of students in this course, okay? And we have several ideas, and in the end we shall come up with a scheme of evaluating your performance, which will give us whether you will get an A or a B or whatever, DD, etc. in this course. If we hold an activity like that, which produces at the end, the input is a very rough assessment scheme, and the output is a scheme which we have decided upon, okay? This sort of activity would be issue-based because there are no actual physical activities taking place. But it is still an activity, a mental activity. So very roughly, you can distinguish between root definitions as primary or issue-based by trying to see whether they involve physical activities or mental activities, very roughly, okay? But it doesn't mean that all root definitions are divided like this definitely. It says, never work exclusively with either primary task or issue-based root definitions. Most investigations will best feature a mixture of both types. So normally, root definitions will include physical activities and also decision or mental activities. So they are, but it is useful to make this distinction and understand this. Step number 5 is the final step. We started with PQR, given PQR, a root definition, the CATFO analysis, the 3 E's. PTIB is also, we have an idea whether it is primary task or issue-based. All you need is, the remainder of your work is just logical thinking to construct the model. The most common error in constructing these activity models is to forget that you are trying to model what is written in the root definition. You are trying to model what is written in the, this is a notion, it's an idea. You are not trying to model the actual activity which takes place in the real world. You shouldn't forget that. It says the most common error is to take your eye off the root definition and start modeling some real world version of the purposeful activity being modeled. You're not modeling a real world version at all. The 5 steps of constructing purposeful activity models is summarized here as a diagram. At the top is step number 1, the PQR formula. Do P by Q in order to contribute to the achievement of R. That provides a shape, the PQR provides a shape for our root definition. Let's go to step number 3 now. In step number 3, the mnemonic CATWOE, each of these are identified. It's written what each of them signifies. And that enriches the root definition. Okay? The CATFO, therefore, actually is written probably before the root definition. Or you can start with the root definition and do the CATFO later on, and then modify the root definition accordingly. It's any way you like. The root definition tells us in number 4 that it could be primary task or issue-based, or more usually a mixture of both. And in step number 5, we identify the model itself. Let us consider, in the remaining 15 minutes or so, let us consider the Bakü-Ceyhan example and see how a root definition can be formulated in the Bakü-Ceyhan case. Now remember, in this problem situation, there were different stakeholders. There was the port manager, who is the top executive there, who is interested in reducing total costs of pumping, etc. Then there was the pumping officer, who is the engineer responsible for overseeing the pumping operation itself. And there was also a third manager, the maintenance manager. He's another engineer who is responsible for the reliable operation of the pumping system. So these three people, for example, for the same problem situation, might have different root definitions. So this is a useful example because their Weltanschauungen are not the same. So it's a nice example to explain all these complications. Now, assume for simplicity that each person's viewpoint can be expressed in its own single root definition, even though there will be cases where one person may construct several root definitions. So this is another point that you have to consider. I mean, sometimes it doesn't mean that each root definition corresponds to one and only one person and vice versa. Huh? The same person can come up with different root definitions. That's also possible. But to keep it simple here, we're going to assume that each has one root definition. The following root definitions can be inferred from the dialogue. The dialogue we have seen taking place between the port manager, the pumping officer, and the maintenance manager. The port manager is responsible for the entire operation of potash. He wishes to keep down his overall costs, as we know. A CATWO for him can be developed taking the host system as the relevant one. The transformation system is the host system, which is used for pumping. The transformation is probably that the hose takes crude oil from storage tanks to tankers at minimum overall cost. In CATWO, we said that it is best to start with identifying the transformation process itself. So for the PM, the transformation process, what could it be? Probably it could be this one. What is the transformation? It's taking the oil in the land tanks, karadaki tanklardan, land tanks, and transforming it into oil in tanker ships tanks. Okay? That's the transformation process at minimum overall cost. So in this case, the customers are the potash. Now this is the CATWO, okay? Let's see the entire CATWO. This is the entire CATWO for the PM, for the port manager. You remember the customers, who are they? These are the people who are going to bear with the results of the transformation, who are going to endure the results, the conclusions of the transformation process, either as victims or beneficiaries. We can call the customers as potash, all personnel. The actors, who are they? These are the potash workers and tanker operatives. The transformation itself has to be carried out, but obviously by potash personnel, and also tanker operatives. I mean, tanker operatives are the personnel of the ships, the tanker ships. They also have to take part in the pumping operation, obviously. The transformation is transfer oil from tanks into bulk carriers. Bulk carriers are these tanker ships. The Weltanschauung is, I mean, this is what we surmise, this is what we infer from the conversation that we have read before. I said here on the previous page, in parentheses there, in the third pointer, although you may read things somewhat differently. I mean, when you read that conversation, maybe you can come up with a different CATWO for the PM. It's possible. This is just one possible CATWO. So the Weltanschauung of this CATWO: need to supply markets with oil at minimum cost. Or we could write it, we should try to supply markets with oil at minimum cost. This is our worldview. Otherwise, why would the port manager be concerned about keeping down his costs? It's good to do all of these operations at minimum cost And the worldview that supports it is that, of course, oil has to be provided to world markets at minimum cost. Notice that we are talking about cost, not price. We are not talking about oil prices. The owners are probably the government who could stop this transformation. I mean, the pumping of oil to international carriers, ships, cannot be stopped by the port manager. Probably the government can do that only. Environmental constraints would be pumping rates. I mean, how many liters of or hectoliters of oil can be pumped per second, etc. These are technical constraints, pumping rates. Sea conditions, obviously. Sea conditions, if the seas are rough, then pumping may have to be stopped or slowed down, etc. And environmental concerns about possible pollution because of leakages, etc. So all these constraints are environmental constraints. So having conducted this rather straightforward cat-flow analysis, now we are able to write a route definition. Now this is the route definition at the bottom of the port manager. As you can see, the route definition is not a very short statement. It is detailed and it is long. The best route definitions are like this, because the model itself is going to be constructed on the route definition. So the activities and all the other measures of performance, etc., will come out of what you state in the route definition. So the route definition should be rich enough to provide that possibility. A system owned by the government and operated by BOTAŞ staff with the cooperation of tanker operators to transfer oil from the Ceyhan tanks to waiting bulk carriers at minimum cost. It must operate within physical constraints such as pumping rates and sea conditions, plus environmental constraints. The system is needed so that oil can be supplied to world markets at minimum cost. This is our route definition. It defines the system that we are trying to model in words. Okay? So that's a first example. Let's look at a second example, and then I'll let you go. This is, actually we have three examples, both PM, PO, and MM. But let's consider the pumping officer now, what his route definition might look like. Now, the customers for PO are different, as you can see. The customers are the tanker operators, because this pumping officer is responsible not for minimizing costs and supplying oil to world markets, etc. He is responsible for the safe conduct of oil from land to sea, for safe and reliable pumping. So his customers are tank operators, because the consequence of his transformation process will be either beneficial to the tanker operators if pumping has been on time, with minimum hassle, no trouble, etc., or will be the victims of the operation if, for example, there's a rupture of the hoses and a spill, an oil spill, and other costly and long repair operations. So tanker operators are the customers. The actors are the same as before. The BOTAŞ workers and tanker operators are operatives. The transformation is hose takes crude oil from storage tanks to tankers. We are not concerned with minimum cost. The PO may not be concerned with minimum costs. The Weltanschauung of the PO is, my job is to provide a reliable service to tanker operators. That's his worldview. The owners are BOTAŞ, because BOTAŞ can stop temporarily probably the pumping. This is not, the owners here are BOTAŞ. The owners in the previous route definition was the government, because for the port manager, stopping the pumping is a major pumping operation. Here we are concerned with an instance of pumping, because the pumping officer has no authority to start or stop pumping, okay? pumping will start according to schedule, and for the pumping officer, stopping the pumping is within the authority of BOTAŞ, okay, for an instance. The environmental constraints are probably the same, pumping rates, sea conditions, and environmental constraints. The need to keep costs down can also be included here as an environmental constraint, because for the pumping officer, the boundary judgment is made by the PM so that it would be all their concern to keep the cost as low as possible, the cost down as low as possible. So his route definition might read something like this: a BOTAŞ-owned system to transfer oil from Ceyhan tanks to waiting bulk carriers as reliably as possible, operating within physical constraints such as pumping rates and sea conditions, plus environmental constraints and within cost limits. So cost limits are now an environmental constraint for the pumping officer. The system is operated by BOTAŞ workers and tanker operators, and is needed because my job is to provide a service to tanker operators. So this is, it is similar to the route definition of the port manager, but not the same, as you can see. So the purposeful activity models will also be different. The last one is the maintenance managers. So as a result of these, in the Bakü-Ceyhan example, we will end up with 3 different purposeful activity models. What's the issue? The issue is that these 3 different people, facilitated by the industrial engineer, are going to come up with a decision to act. What's the decision to act? It is whether about to change the host system from ABC host to XYZ or TUV host, and also to make changes in the maintenance policies, okay? How these policies and these decisions are going to be arrived at will be the result of the discussion between these 3 stakeholders, and the discussion will be facilitated each by viewing the other's purposeful activity models, how they see the operation in their minds as notional systems. Okay, so let's stop here.